everyone, and welcome to lesson 11.0, day 4. Today we are going to talk about the area of trapezoids and rhombuses. When we calculate the area of a trapezoid, we want to calculate it by using 1/2 the height, so again the distance between your two bases, and then the sum of base 1 plus base 2. So if we look at example A, our two bases are going to be 3.6 and 11.4, and our height is that distance between those two bases of 7. So really, we're not even using the 8.1 and the 7.9 when we're calculating this area. We're just taking 1/2 that height and then base 1 plus base 2. So again, we're going to type that in, 1/2 times 7 times, again, the sum of 3.6 plus 11.4. So we definitely want that in parentheses. We're going to add that together first before you plug it in. You should get 52.5 square feet. Now on our second example, we are only given the first base. We aren't given the second base, but we are given one of the legs of this isosceles triangle and the fact that this angle here is 60 degrees. And we've talked a lot lately about 30, 60, 90s. So if that hypotenuse is 14, we know this piece is 7, and that height is 7 square root 3. Well, if we drop down on the other side, which also, again, showing this congruent with the 7 square root 3 and the 14, this is, the 60. This is going to be 7 as well. So what this tells us is that if we take 26, minus 7 minus 7, this is 12, and that's our other base over here. And then we also were able to calculate the height by using our 30, 60, 90 as well. So we have base 1 is 26, base 2 is 12, and then our height here, 7 square root 3. So our area is 1/2 7 square root 3, base 1 plus base 2. And again, if we type that in, 1/2 of 7 square root 3, and then our two bases, 26 plus 12, we get a final area of 230.4. On our last example, we are given the two bases. However, we again are not given that height. So on this one, since it's a 52-degree angle, we don't have a shortcut. The best we can use is that we are looking for that opposite side, the height. We are given the hypotenuse of this little right triangle that's being created. So to find that height, we could just take 21 times the sine of 52. So as always, double check that your calculator is in degrees mode. So if it's 52 degrees, 21 times the sine of 52 degrees is 16.5 for our height. And then as we actually calculate the area, it's 1/2 our height of 16.5, base 1 and base 2 added together. It ends up being 519.7, in this case unit squared, since we weren't given exact. All right, so the two on the bottom are for you to try by yourself. You are finding the area of our first trapezoid. On the second one, you are going to need to find this height first. Think about what that means in a 45, 45, 90, and then calculate the area. As we move to the next page, we start talking about the area of a rhombus. And a rhombus is going to have two different formulas because officially a rhombus is a parallelogram. So base times height could work as the area. It also has a second special formula, which is just 1/2 diagonal 1 times diagonal 2 to find the total area as well. So it's a little bit dependent upon what you are given. So on this first one, we are given that we have a base of 6 and a height of 9. So 6 times 9, we have 54 square centimeters. On the second one, we are given the piece here is 7, the height is 24, but we actually aren't given the full side length. So what we're going to do is we're going to use a little Pythagorean theorem to help us solve. So c squared equals a squared plus b squared. So c squared is 625. And when we square root, our side length this time is 25. So that ends up being our bases because we know all the way around these four sides are all 25, aka that is our base. So when we calculate area, is that base times the height, we end up with a total area of 600 square inches this time. In number 3, they are telling us that we have a side length of 22, aka the hypotenuse of this 30, 60, 90. So if we divide by 2, we know that the side across from our 30 is 11, and our height ultimately is 11 square root 3. So again, this is that perpendicular height, and our base then is just the 22, all that we have for all four sides. So 22 times 11 square root 3 is 419.2 square feet. Last example, we are given the length of diagonal 1 is 4.4. The length of diagonal 2 is 3.5. So when we calculate the area, this time we're going to use that 1/2 diagonal 1 times diagonal 2 formula. So 1/2 of 4.4 times 3.5, 7.7 square yards. The last page has 3 examples for you to try. The first, you are given the base and the height. Find your area. The second, you are given the base. You need to find the height and then ultimately the area. And then last but not least, you are given the 2 diagonals. Find your total area. Thanks everyone for watching, and we'll work more with these area formulas in class.